A little housekeeping. So the audio is provided via internet. If you have any questions throughout the webinar, go ahead and type them in the questions tab on the panel. I'll go ahead and read the questions and answer them at the end of the webinar. And everyone that registered for this webinar, you will receive a printout of the slides and a link to the recording of this webinar. It will also be recorded and placed on the Exceda YouTube channel and the Exceda website as well, under webinars. Today we're going to talk about what is safety culture. We're going to look at numerous field failure studies and see how the failure rate for a specific device, meaning the exact same manufacturer, the exact same model, will vary from site to site. And we're not talking just from company to company, but actually the same company, site to site. So we wanted to look more into this, so we started researching what was going on. And we found that random failures can be divided into two categories: product-specific and site-specific. The difference in the failure rates could be any range from 1.2 times to 2 or even 3 or 4 times based on the data that we've received to date. The Site Safety Index, the SSI, was created to account for these failure rates differences as well as other variables. Exceda has written the Site Safety Index information into the FMEDA reports to provide an overview on the Site Safety Index model used by Exceda to compensate for site variables, including device failure rates. So today, what will this webinar do? We will first look at the overview and the impact of the Site Safety Index on random failure rates. We'll look into realistic PFD average calculations and the impact of good safety culture on life cycle costs, along with reviewing the changes in the Exceda FMEDA report. Quickly about me, my name is Lauren Stewart. I'm a CFSP. I am working at Exceda, focusing mostly on our mechanical customers. Along with product certification, I am doing some alarm and end user work, along with researching mechanical failure rates, stiction, and the 2H initiative. Exceda has worldwide locations, so no matter where you are or where your customers are, we have someone close by that can help you with all of your functional safety needs. We like to say anything related to functional safety we have a part of. So whether it's the process, the products, or the people, if you want functional safety, we cover it. We do consulting, we have engineering tools, we do product certification and training, we have reference materials, and our personnel certification. Talking a little bit more about some of our reference materials, we're really proud of how many books we have authored in the functional safety realm. We at Exceda like to be an open book. If we are doing it, if we're saying it, or if we've researched it, we have it published in books and webinars and white papers and blogs. We want to make sure that we're not keeping anything from you. We want you to know exactly how we're doing things and why we are doing what we are doing. So let's get into why you're here today and the awareness of safety culture and what Exceda is doing about it. The Site Safety Index. We are going to break it up into 4 major topics. And we're going to start with an overview and the impact of Site Safety Index on random failure rates. We're going to look at the realistic PFD average calculations. We're going to then move into the impact of a good safety culture on life cycle costs. And finally, we're going to look at the changes to the exida FMEDA report and how we capture what is going on with the site safety index information we are using. So you may be sitting there wondering right now why we're saying site safety index instead of maybe company safety index. Well, as I said before in the introduction, it is actually pretty well documented that a safety product may exhibit a safety performance less than or even better than specified by the manufacturer or the FMEDA. And we noticed that that was happening from company to company, and we started taking note. Then what really piqued our interest was when we were within the same company looking at it from site to site, and that there were differences from actually site to site. Studies have shown that failure rates estimated from field failure data for the identical models in the same industry, the same type of application, same way of using it, same environment, exhibit differences in the estimated failure rates for the same product site to site. Typically, when compared to a predicted failure rate, such as an FMEDA, the field failure data estimates are approximately 1.2 to 2 or 3 or even 4 times higher, depending on the product type. So site audits have attributed these differences to dissimilarities in end user activities and the practices on what is going on in maintenance or operation from site to site. This variation in end user activities and the practices can be captured in the Site Safety Index. So while the company-wide policies and procedures might be the same and it will impact the safety achieved, it is possible that different ways company look at those procedures or implement those procedures on a site-to-site basis requires that the Site Safety Index or a safety index be measured at the site level. So further, these variation in activities and practices directly impact many variables used in different calculations which assess the safety performance of a SIF. So without proper safety culture at a site, having certified products, it really won't matter. If you can have the best device in the application, and if you're not doing the correct things, that device, it doesn't matter if it's certified or not. Why this is that human factors play a part in safety system performance. There could be imperfect repairs, improper calibration, faulty installation, not doing the repairs in a timely manner, and many other factors contribute to the decrease in functional safety performances. So what is the Site Safety Index? Well, the Site Safety Index is a model of a simple approach based on concepts from IEC 61508 to more accurately account for site-specific operational practices. And the Site Safety Index is used to adjust the safety metrics computed under the assumptions that human factors play no part in safety system performance to reflect the effects of real human factors on that safety system performance. And this can be broken down based on a site-to-site basis. So this approach allows a site with really strong safety processes, they're doing everything right, they're doing everything on time. Well, you can take credit for that accomplishment. That is a big deal, and we don't want your site to be punished because of other sites in the company. We don't want to mask other issues at other sites, but we want you to have that accomplishment be reflected in your safety calculations. So there are currently two ways that Site Safety Index can be evaluated. There's an external audit, which provides the most accurate measure of the Site Safety Index, and also by a self-administered questionnaire, which relies on less information than the audit, and it provides an approximate measure of an SSI. So the first way, an external audit. What goes on? Well, the international standard IEC 61511 lists the requirements that must be met for the entire safety lifecycle process. In an on-site audit, it can be verified that the site meets these requirements in combination with additional detailed requisites for the operations and maintenance activities. Additionally, all the safety and the life cycle procedures are audited to make sure that the procedures are adequate to support the requirements and also that they are being correctly followed at that site. You can have all of the perfect procedures to meet every requirement, but if they're not being followed, who really cares? The outcome of this audit is a report which includes your Site Safety Index score obtained, as well as recommendations for changes or recommendations for future improvements. The interpretation of the measured Site Safety Index level itself we will get to later on in this webinar. So the second way is from a self-administered questionnaire. So a site that's interested in inquiring about or an approximation of the measured Site Safety Index of its current state of their safety culture may choose to complete a questionnaire of about 40 questions, which represent a subset of the information gathered in a complete audit. So these questions cover various stages of the life cycle and various activities and practices spanning a portion of the life cycle of the SIF. It can be broken down into installation and commissioning, the safety validation, operations and maintenance, SIF modification, and finally decommissioning. So here's a look at a few of the sample questions for just the operation and maintenance phase of the life cycle. The complete set of questions can be made available and is in our Excelencia tool, as well as some white papers. The questions you go through and you answer the questions through saying always, often, never, or not applicable. And the questions are weighted by each subject on which one's more important. The total score received determines an approximate safety index level for that site. And based on the validity of using the questionnaire for determining a site safety index is the accepted practice per IEC 61508 of using a questionnaire to determine the beta factor that describes the extent of common cause failures to be modeled when evaluating the safety performance of a redundant SIF architecture. So if you look through these sample questions, just to get a little idea of what we will be asking, looking at your maintenance records of proof tests. Are the as-found conditions reported? Are the results of the tests and inspections reported? Do you do any repair of any deficiencies found during the proof test in a safe and in a timely manner? Are your proof tests performed on schedule? Is the frequency of proof tests decided using your PFD average calculation? And these are just a few of the examples of the operation and maintenance phase. So the Site Safety Index model is evaluated on 5 levels, and this is from the Excelencia program, going anywhere from Site Safety Index level 0 to Site Safety Index level 4. And these are indications of the level of site activities and practices that contribute to the safety performance of that SIF on the site. So this table details the interpretation of each site safety index level. And if you can see, it kind of mirrors the levels of the safety integrity level or the SIL rating assessment. And it's the same as it. Level 4 implies that every single requirement of IEC 61508 and IEC 61511 are met at the site, and therefore there is no degradation in safety performance due to any end user activities or practices. That the product is completely inherently safe, and if it needs to perform its safety function, it can at any moment. And it's saying that you're perfect, that repairs are always done correctly, they're always performed on time, the testing is done correctly and on time, equipment is always replaced before the end of useful life. And I don't know about you, but I'm human, I'm not perfect. So that is a level kind of like the SIL rating of SIL 4. It's this unicorn that is a very, very high target that is not necessarily achievable. Nobody's perfect unless you use no humans. To the other extreme, where SSI 0 is none. You don't do repairs, you don't do testing, you don't replace anything until it has absolutely failed and there is no getting around it. And hopefully, once again, that this is an exaggeration and no companies out there are doing absolutely nothing. But you never know. So I wanted to quickly show you the impact of Site Safety Index in a Excelencia example. So for those of you that don't know, this is our Excelencia tool, and it can do many, many, many things, but this is just a quick example and screenshots of it. So in this example, we want you to take a note of the things circled in red, so the achieved safety integrity level and the risk reduction factor. So the specific ways that the Site Safety Index modifies key variables such as a device failure rate, proof test effectiveness, etc., which all impact the PFD average, the SIL level, and the risk reduction factor numbers, as well as other safety matrix. So in this example, the computation was performed under the assumption that the Site Safety Index is a level 4, 100% perfect on everything, always. And thus, any end user activity and practices will not compromise the safety performance of the SIF. So take a look here in the top red circle, you have a SIL level of 2. That's great. So, and that's based on the PFD average, And then the risk reduction factor is circled below that as 113. So the next screen we're looking at here is, once again, Excelencia. This is the exact same everything, except we went from a safety index of 4 down to a site safety index of 3. And site safety index of 3 is still rated as superior. You're still doing many of the things right and many on time. You understand that humans make mistakes every once in a while, but you're doing really, really good. And just taking a look, all of a sudden your achieved safety integrity level is down to a SIL 1. And your risk reduction factor is down to a 98. Well, this just shows you how the impacts of site activities and practices can be quantified and how effects of changes to these activities and these practices are measured. The Site Safety Index provides a simple means to measure how well a site-specific end-user activities and practices support the achievement and the retention of a SIF. Further, they can be used to adjust the matrix of the SIF safety performance from this ideal achievable, this unicorn, to a more realistic measure of what is actually attained at a specific site given the site activities and practices. So the major impact that we want you to take away is that a key metrics for process industry design is called the PFD average, or the probability of failure on demand. After several studies of many field failure and proof test reports, several variables, which we'll get into a little bit later, have been identified as key to a realistic PFD average calculation. So here is a little information from the white paper that we are getting, one of the white papers we are getting this information from. And this is what are the 9 key variables for the PDF average calculation. And as you can see, there are many things here, and one of them is a site safety index. So this is how end user practices will affect the SIF. But how many of these are really impacted by site safety index? So this isn't just number 8 here. Let's see. The failure rates of each product. Yep, absolutely. And the actual proof test interval, not just the ideal proof test interval. The actual proof test effectiveness. The actual mean time to restore. And the probability of initial failure. So clearly, redundancy of devices is not an attribute of end user practices or activities. The Site Safety Index itself is not modified in safety performance calculations. Rather, it is used to modify many of the other variables which impact PFD average and other matrices. Specifically, if you go from the Site Safety Index that's less than 4, so if it's not 100% perfect, these 5 key variables are modified. And this is just showing that the Site Safety Index accounts for the differences between the targets and what you're hoping to get during the conventional calculations to what's actually happening, or the reality of a site due to the impact of operational processes. So why is this important? Who really cares? Well, these key variables in PFD average calculations are impacted by site operational practices. A model can show this impact and could be used to show benefit of improved operational processes. Not only that, you can also justify and show lifecycle cost comparisons can be done. So you can take this information to the manager that doesn't care about the operational process. This doesn't make sense to him. He wants to know exactly what this will cost him and what will be the justification for doing these correct practices. So several factors have been identified thus far which impact the Site Safety Index, and these are shown in the FMEDA report and also in Excelencia. The commissioning test, safety validation test, proof test procedure documentation, the failure diagnostics and the repair procedures, device useful life tracking and replacement processes, SIS modification procedures and decommissioning procedures, and many others. So how are these key variables impacted by site practices? Well, you have the failure rates of each product, the actual proof test intervals, the actual proof test effectiveness, the actual mean time to restore, and the probability of initial failure. So we're going to look at each of those a little more in depth. First of all, we have the failure rates, and we're going to look at how they increase as the lower your site safety index goes. So your FMEDA failure rates for each product predictions assume that the products are installed in an environment that has been verified according to the manufacturer's specifications, that the products are chosen with materials comparable or compatible with any process chemicals, and that the products are commissioned and calibrated according to the manufacturer's instructions. So, but in lower site safety index level, think of that site safety index of 0. Nothing is being done. These activities are probably not being done in a site safety index of 0, maybe not even in a site safety index of 1. So that increases the probability of failure, thus the failure rate. So a field failure study based on billions of operating hours indicated that the failure rate multiplication factor was between 1.2 and 2. Next, the proof test intervals increase. In site surveys done by exida, it was apparent that proof tests were postponed in sites where a high level of operational discipline was not present. So the actual proof test intervals are increased in lower SSI levels. What about the effectiveness? Proof test effectiveness decreases when procedures are not clear, or the test personnel do not have sufficient time or sufficient training and or documentation to do the testing. So the actual proof test effectiveness is decreased in lower site safety index levels. The mean time to restore is increased. So the mean time to restore may increase when diagnostic procedures are not well documented or understood. The mean time to restore will increase when proper tools are not readily available. Some restore efforts will not be successful when personnel do not have enough sufficient time to perform, or they do not know what the documented results should be. Their training isn't there. Then a second effort is needed to do the same job. So the actual mean time to restore is increased in lower site safety index levels. And the probability of initial failure. So products used in a safety instrumented function may not operate properly if they have not been installed correctly, if they have not been calibrated and tested during a complete commissioning process. When the procedures are not clear and the time is not available or the training was not done, the probability of initial failure will increase. So the probability of initial failure is increased the lower the site safety index levels go. So here's a screenshot of the new way we are documenting this, and this is through the FMEDA. In the back of the report, there is an appendix, and this is Appendix E. This is all pretty new, and this goes through a quick, brief way of what we've been talking about today. Then, close up, after the introduction of what a site safety index is, you're going to have this table. You're going to look at the application, the device, the configuration, and this is just an example of a valve. And the failure rates will be listed as safe detected, safe undetected, dangerous detected, dangerous undetected, no effect, and external leak. And you will have the failure rates assuming the site safety index is 4. Everything is perfect. Nothing has been neglected or even delayed. So the failure rates of each individual device in the SIF are increased or decreased by that specific multiplier, which is determined by the site safety index value of the device itself. It is known that final elements are more likely to be negatively impacted by less than ideal end user practices than, say, such a sensor or a logic solver. By increasing or decreasing device failure rates on an individual basis, it is possible to more accurately account for the effect of site practices on the safety performance. So you'll see the regular failure rates in the main body of the report. You come back to the appendix and you'll see what it would be for site safety index of absolutely perfect. And then we also are listing them if applicable for dynamic application, so something moving often and not in a low demand mode of operation. So what should you take away from this? Well, the site safety index will perform more realistic PFD average results. It will, compared to simply adjusting the failure rates, this approach allows a site with a strong safety process to take credit for that accomplishment while not masking issues at other sites. It can show the impact of different operational policies and could be used to show the benefits of improved operational processes, and it can be used to justify improved operational processes. So these are 3 of the white papers that information came from this webinar. If you want more details on any of these topics, please feel free to go and look at the white papers. You can download them for free from our website and read up on many other functional safety issues. So I'm going to quickly go through and see if there's any questions. And if you don't have any now and think of some later, please feel free to email me. And we don't have any at this point. I would like to thank all of you for joining me today, and I hope you have a wonderful evening.